In the world of scientists, who was the greater genius among the two most popular scientists?
Can we say Einstein was a lot smarter than Newton?
No, actually, if you want to put them head to head, I think I put Newton ahead.
Einstein comes next after Newton.
My favorite physicist is Isaac Newton.
If Newton were around in Einstein's time, Newton would have done it all. If Einstein were around in Newton's time, not so much.
These are some of the most popular scientific minds of today's generation, and all have declared Isaac Newton as an unrivaled genius, meaning a genius like whom has never been born. In fact, Einstein himself wrote in his autobiographical notes that Newton was a creative genius of the highest order, but such a brilliant scientist whose theories were considered unchangeable for 200 years. And even today, Newton's laws of motion are taught in schools and colleges. Einstein is mentioned only when you reach degree college. But ironically, the first person to challenge Newton was none other than his deepest admirer, Albert Einstein. He conducts a small experiment. If I drop this ball by hand, what will happen? According to Newton, the ball will go down and hit the ground due to gravity, which is a force that attracts two objects to each other, like the ball and the earth. In this case, but according to Einstein, this is incorrect. Gravity is not even a force. In fact, gravity is just an illusion, and the ball is not even falling down. Rather, the ball is standing in its place. So then, is the ground coming up? And let me ask you one more thing. If I place a ball on a table, tell me, is this ball in inertia or is there any force on it? In physics, inertia means the tendency of an object to retain its state. If it is in motion, it remains in motion. If it is stable, it remains stable. Unless an external force acts on it, so in the example of the ball kept stable Newton would say, it is in inertia, because it is stable, but Einstein would say there is a force of acceleration on it. In fact, when you release the ball from your hand, the ball comes into inertia. Well, you will find many such contradictions when you compare Newton's and Einstein's theories face to face. But in the end, Einstein demonstrated through his special and general relativity theories that Newton's theories were incomplete. And today, the world believes this. So, if Einstein proved wrong the very thing Newton is most known for, gravity, then why did Einstein still consider Newton to be one of the greatest geniuses in history? Was he just trying to appear humble in his autobiography? Just like when the greatest rated chess player in history. When Magnus Carlsen was asked who the best is, he skipped his own name and mentioned his inspiration, Garry Kasparov.
I think Gary is the best of all times.
And was everything we were taught about gravity in childhood wrong? Well, friends, today in this video we will find out exactly why we are still being taught Newton's theory, even though the world knows it is incomplete. What exactly were the flaws in Newton's laws of motion, his mathematics, and his explanations that Einstein noticed and even fixed? We will also learn how the experiment shown to visualize Einstein's gravity can be misleading, which might prevent you from understanding gravity correctly. Finally, we will consider rationally what Einstein saw in Newton that made him call Newton a greater genius than himself. This will help us better judge who was the greater genius among the two. So, get ready, because this video is going to challenge your understanding of reality in a profound way. So, let's begin. 400 years ago, in 1633, the Roman Church threatened Galileo Galilei that if he did not stop promoting his scientific ideas, he would be sentenced to death. Galileo's discoveries, were proving the statements written in the Bible and the beliefs of that time to be incorrect. At that time, people believed that our Earth was the center of the solar system and that the Sun and other planets revolved around it. This model is called the geocentric model. But Galileo himself observed 4 moons of Jupiter through his telescope, which were orbiting Jupiter. This meant that not everything was revolving around the Earth. He also observed the different phases of Venus, which meant that it too was orbiting around the Sun. This was direct proof that Copernicus's heliocentric model could be correct. And the church was wrong, but the church did not accept this truth. And therefore, in 1633, Galileo was sentenced to life, imprisonment for spreading false knowledge, and going against religion. We declare that you, Galileo Galilei, are condemned to formal imprisonment in this holy office. At you. He was banned from publishing research, writing books, and teaching science. And in 1942, he died while still suffering the punishment for speaking the truth. But as they say, the truth can never be suppressed, it never hides, whether by coincidence or otherwise. In exactly the same year, 1642, on Christmas Day, a person was born who would bring this suppressed truth to everyone. It was as if Galileo had been reborn in a different body, because this person was none other than Isaac Newton, born in Lincolnshire County, England. Sir Isaac Newton was born at a time in history when subjects like science were just beginning to be introduced, like the ABCs. Newton came from a troubled family. His illiterate farmer father died 3 months before his birth. When he was 3 years old, his mother married a rich man who did not even want to adopt Newton. Due to this, Newton spent his entire childhood, with his grandparents in the absence of his mother, and this feeling of abandonment probably gave him the shock that made his personality very different. Being absolutely loath, not trusting anyone, holding on to things, being extremely obsessive, taking revenge. These are some of the bad personality traits of Newton, which you will see at many places in his biographies. Like he later made a list of his scenes in which he described the Thor of his teenage. In that, he wrote that at one point, he became so frustrated that he had thoughts of burning his mother and his stepfather. But anyway, her mother divorced in a few years, and she came back to live with Newton. At the age of 15, she wanted to drop out of Newton's studies and put him to work farming the ancestral land. But Newton was made of a different material. In fact, even while farming, he would often sit under a tree and solve math problems. His school headmaster recognized Newton's talent and convinced his mother to send him to Cambridge for his studies, which is where Newton's journey to greatness truly began. I mean, how much of a role did his headmaster play in Newton's success? By recognizing his abilities and guiding him in the right direction. As soon as he entered college, he quickly realized that outdated concepts were being taught here. For example, according to Aristotle's time physics, there is no such thing as gravity. Every object has just one natural tendency to move from a non-state to a state of rest. For example, when you drop a ball, it falls to the ground and comes to a state of rest. The larger the object, the greater its tendency will be to come to a state of rest. Now let me ask you a common sense question. To answer this, I take two balls, one larger with more mass and the other smaller with less mass. Now, if I drop both balls from the top, which one will hit the ground first? What does your common sense tell you? Well, according to Aristotle, the ball with more mass would have a greater tendency to come to a state of rest. And that's why the more massive ball would fall first. But Newton couldn't digest this idea. Well, Newton couldn't accept one more thing about the Aristotelian physics of that time. An object needs a constant force to keep moving forward. If the force stops acting, the object will stop moving. Stop because remember, every object has a natural tendency to remain in a state of rest. That means for Aristotle there was no concept of inertia, so no concept of gravity and no concept of inertia. Now, why Newton was not able to understand this? Because his own inspiration, Galileo, had already shown in 1859 by doing an experiment on the Leaning Tower of Pisa that if two balls are thrown together, then both the balls actually fall down together. I am respectful of the mass, so the mass of the objects being more or less has no much link with the falling down first. And that is why, in their passion to discover the truth alone, scientists and philosophers with modern ideas like Newton, Galileo, Copernicus, Descartes, etc. started self-studying the books of cavalry. Just imagine, you went to college to study, And within a few days, you realized that they were teaching outdated concepts, so you started studying on your own. Scientists with such thinking achieve remarkable things. He also created a special notebook called Question Coin Philosophy, which means certain philosophical questions, in which he wrote something very beautiful. Aristotle is my friend, Plato is my friend, but is my best friend. After 6 years of self-study during his university days, Newton began to gain clarity on the concepts of motion and gravity. When Newton saw things falling down, two powerful thoughts came to his mind, and both thoughts eventually led to two major inventions. The first thought was, hey, these things fall downwards. Isn't this tendency due to some force? And isn't this same force what keeps our moon in its orbit around the Earth? By that time, Kepler's laws of planetary motion had already been established, and that is why Newton knew that the moon revolves in an elliptical orbit around the Earth. But no one knew why. For some reason, it was just assumed that it orbits. So Newton just had to somehow prove that the force that makes the apple fall is the same force that keeps the moon orbiting around the Earth. And that's how the concept of gravity was discovered. Now, this idea was not present during the time of Aristotle's philosophers, nor with Galileo or Copernicus. No one ever thought about how a force that attracts two objects is also keeping the moon in orbit around the Earth. Why doesn't the moon crash into the Earth? They understand this from the example of Newton's own thought experiment, Newton cannonball. If you shoot a cannonball from the Earth with low force, then it will get attracted below the Earth and it will fall down. And on the other hand, if you shoot it with very high force, then it will directly fly into space, tearing through the Earth's atmosphere, just like rockets do. But if you apply just enough force that it cannot even pull it down to the ground, and it does not have enough forward acceleration to make it fly straight into space, then it will just keep falling down forever, but it will never touch the ground of the Earth. He referred to this as one more bit, that the same force that is making things fall down is also keeping the moon revolving around the Earth. They just had to prove it mathematically. Now, how do they just watch? But before that, the second thought that came to him while observing falling objects was this. What he realized was that as soon as an object falls, we can easily measure its speed of falling. Distance is calculated using the formula of distance over time. But the problem is that this formula only calculates the average speed of the object as it falls. If we want to find out the exact speed or velocity of the apple at that exact point, after falling for 2 seconds, how can we calculate that? To answer this, they literally invented a new kind of math that is now used in literally 80% of physics. Calculus. Physics is all about the change, and calculus describes it. The only constant in the universe is change, and that is calculus. It's a mathematical tool that predicts those very changes. How something will evolve is described by calculus in motion. Just like this equation of a falling object describes calculus, electricity, and magnetism, just like Maxwell's equations, describe calculus in general relativity. Just like Einstein's field equations, calculus describes quantum mechanics. And similarly, calculus also describes thermodynamics in the Schrödinger equation, and much, much more. So, Newton had basically learned to mathematically describe the motion happening on Earth. Now, they just had to learn to mathematically describe the motion of the nearby planets, so that they could prove that gravity works the same way on Earth and throughout the entire universe. This is a universal force, and after years of hard work, they finally developed the universal law of gravity by corroborating falling objects, the motion of the moon, and Kepler's third law of elliptical orbits. This is the equation that is also known as the inverse square law. Now notice one point, even though this universal equation was developed by Newton, the idea of inverse square law was older, for which Newton gave credit to Ballia and Borelli. They had already hypothesized that there is a force from the sun, whose impact decreases by half with every square distance. But no one had been able to connect these ideas and prove them mathematically like Newton did. Only Newton could do it because he was a mathematical genius. And from this, we learn one thing. In my opinion, scientific discoveries involve 60% imagination and ideas and 40% mathematics, which helps prove that idea, gives direction to the idea, and mathematics goes that far. And that's why Einstein also said that imagination is more powerful than knowledge, so never let your imagination stop. From these learnings, Newton then published his 3 laws of motion in his book Philosophia Naturalis Principia Mathematica, along with the concept of gravity. In this book, a strong framework for modern physics was established, making Newton's book like the Bible of science, and Newton completed his work happily. He passed away on March 31, 1727. Now, after Newton's departure, in the beginning, scientists were able to use Newton's model well to predict the planets and their bets. Cracks in Newton's theory began to appear when a small planet called Mercury was not able to open Newton's laws. The Newtonian model was also unable to predict Mercury's orbit. Every time, approximately, the calculations were getting messed up by about 3 lakh seconds per century. Was there a hidden planet whose gravity was interfering with Mercury and messing up these calculations? Something similar happened in 1846 when Urbain Le Verrier proposed a missing planet named Vulcan. But this missing planet Vulcan was never seen by anyone. And because of this calculation mistake, questions began to arise about Newton's theory, leading to the thought that one might not be able to achieve anything in life.
I didn't understand.
These were the words of Albert Einstein's teacher, who was frustrated with Einstein's stubborn attitude. The whole world definitely considers Albert Einstein a genius today. Well, when they were kids, hardly anyone would have thought this. Well, Einstein's childhood was quite interesting. He didn't even learn to talk until he was 4 years old. His parents were worried that he might have some speech defect. Even today, children who do not learn to speak until late have Einstein syndrome. It is said that in his childhood, Einstein was a completely quiet and lost child who used to daydream in his own world. He was average in studies, but he absolutely disliked the concept of a rote learning and answer rules in school. He considered school to be like a prison, where children are made narrow-minded and their imagination and creativity are suppressed. Because of this attitude, some teachers didn't like him. But where Einstein didn't like memorization, he was very fond of asking curious questions, conducting hot experiments, and learning math. And by the age of 12, he had taught himself advanced subjects like calculus, math, and geometry. Between the ages of 12 and 14, he even started conducting real experiments, such as calculating the speed of sound, timing echoes, and building model flying planes and steam engines. During that time, there was one question that troubled him greatly and was going to change his entire life. He was very fascinated by the concept of light, and that's why he often wondered what he would see from his point of view if he somehow converted himself into a beam of light and traveled across the universe. How would this universe appear? He also thought a lot about imagination and even time, fundamentally questioning it. Why is it that time only moves forward in one direction? Now, it's very important to understand the conditions of that time, because only then will we understand where Einstein got the inspiration to become Einstein. At that time, 2 theories of physics formed the backbone of our understanding of reality. One was Newton's laws of motion, and the other was Maxwell's laws of electromagnetism, which James Clerk Maxwell introduced in the 1860s. These reveal that light is nothing but electromagnetic radiation, and his laws describe the motion and propagation of light. Now, at that time, there was no proof, but Maxwell's equations indicated that the speed of light should always remain constant for every observer, which is approximately 300,000 kilometers per second, whether the observer is in motion or static. Alright, understand this with an example. Let's say you are traveling in a spaceship at a speed of 200,000 kilometers per second, and there is another spaceship standing still in front of you. Now, if you shine a light beam from that accelerating spaceship at a speed of 200,000 kilometers per second, what speed of light will the observer spaceship measure? Well, Newton's wild common sense would suggest the speed of light is 300,000 kilometers per second, plus the spaceship's own velocity, which is 200,000 kilometers per second, equaling 500,000 kilometers per second, right? Simple. I mean, if you had launched a missile at a speed of 100,000 kilometers per second, the missile's velocity would add to the spaceship's velocity, and the net velocity would be 300,000 kilometers per second. Okay, I am switching speed and velocity here, so that more people understand speed is commonly used. So this is simple relative motion where two speeds should add up. But in the case of light, this does not happen. The observer will see the speed of light as constant, that is 300,000 kilometers per second. In fact, the speed of light will always remain constant for every observer. Now, because light is an electromagnetic wave, Maxwell's equations were making an interesting claim that a beam of light would have to travel through some invisible medium. For example, Basni, just like sound waves, travel through the medium of air. What medium would light travel through? Well, this medium was named luminiferous ether, or simply ether at that time. But the problem was whether ether even existed, as no one had seen it or proven it. Then, in 1907, two American physicists, Albert Michelson and Edward W. Morley, tried to prove it. Surprisingly, they set out to prove its existence. But they proved that no medium like ether actually exists. And yes, they also validated Maxwell's claim that the speed of light, indeed, remains the same for all observers. So now we had finally reached the point in history where many questions were raised about Newton's theory. If Newton says that all motion is relative, meaning velocities add up, as we saw in the previous spaceship example, then how did Michelson and Morley, by standing up to Maxwell's claims, prove that the speed of light is constant and doesn't add up like other things? Is light special? And it is during this time that Einstein enters the story, and the beginning of the special theory of relativity, in which Einstein considered light as that special element. In 1905, Einstein published a scientific paper to clear up this confusion, which forever changed the direction of the physics community. The paper was titled Electrodynamics of Moving Bodies. And in this paper, he basically rejected the entire concept of ether. Along with this, he also pointed out some glaring flaws in Newton's laws. In this paper, Einstein essentially ousted ether and replaced it with a very minimal and fascinating concept, space-time. So basically, the space that we see all around us and everywhere in the universe is not just space, but it is space-time, which is made up of 3 dimensions of space and 1 dimension of time. Space and time are fundamentally connected to each other. They are inseparable. There can be no space without time and no time without space. So Einstein's model was a totally groundbreaking idea that was going against Newton's theory. In fact, moving forward, Einstein would publish one concept, idea, and theory after another that would expose the incompleteness of Newton's theory. What were those ideas after all? So now, let's move away from the story and do a direct one-on-one comparison of Newton versus Einstein's perspectives on viewing the world. Because sometimes the views of these two scientists seem completely opposite. In school, we're taught Newton's laws, but then, why does Einstein later say that Newton is wrong? Whom should we trace?
After all, Einstein challenged Newton's idea by saying that the apple doesn't just fall down, but rather, the ground is accelerating.
So how can the ground accelerate from all sides? Alright, now very few people know that there are 2 types of gravity, one real and one fake. And the gravity you and I experience is fake gravity. All these concepts are very fascinating, and don't worry, I will cover all these mind-blowing concepts that shape our reality in detail in the next and final video of the series, and in such a simplified way that 1. Even if you are from an 8th grade or commerce background, you will grasp it. The next lesson will be out within a week. See you soon.